Okay, let me explain to you the evaporation and vapor pressure. Okay, it's gonna be a short lecture. Now, vaporization or evaporation is a process um, when the liquid phase, okay, liquid try to escape the surface of of the sample and go into the gas phase. Now, in order to do that, the molecules in liquid phase, for example, if you have water molecules, okay, in the liquid phase, because the water molecules have intermolecular force, hydrogen bonding with another water molecule. In order for this molecule to go from liquid to gas, you have to overcome this intermolecular force. This is why this process is going to be endothermic. So water, okay, for example, water sample, you will need a lot of energy. You need 41 kilojoule per 1 mole water to change water from liquid phase to gas phase. And that energy is just simply used to overcome the hydrogen bonding. So this is why water is special, because two-thirds of our world is composed of water. And because water needs can absorb a lot of energy before it can change from liquid to gas phase. This is why water is just like a energy reservoir. It can suck up the energy and it helps us help the world regulate its temperature. Okay. Condensation is a process that opposite of vaporization. This is when uh, the gas phase of any substance, in this case water is an example, gases molecules in gas phase condense back to liquid phase. This process is the opposite of vaporization. So therefore, this process will be exothermic. Okay. So now, if you put the two process together, okay, like here, if you have water molecules, okay, water sample, you put in a flask, you cap it, make it a closed container. Initially, some of the water molecules in the surface will start to evaporate, change from liquid phase to gas phase. Now, when it goes to the gas phase like this, the water molecules will have nowhere to go because this is a closed container. Eventually, it will have to condense back into the liquid phase. Some, not all of them, some of them will condense back to liquid phase. So now, because it is in a closed container, if you let the system go for a while, it will reach something called equilibrium, meaning that when the system reaches equilibrium, means this at this point means then the number of molecules of water of the substance that change from liquid phase to gas phase will be equal to the number of molecule of gas phase change back to liquid phase. So because the number of molecule that changes between the two phases are equal, you will not see the change in the level of the liquid. And this is why we call this system has reached the equilibrium. But it's not a typical equilibrium, it's a dynamic equilibrium because there's something going on all the time. Yeah. So going on all the time meaning that there's like evaporation and condensation that's going on all the time. So now you can see in this flask, because you have this vapor, okay, molecules in vapor phase, and they're moving around. As they move around, they will hit the side of the container, and then anytime when it hits these molecules hit the container wall, it generates a pressure, and this pressure is called the vapor pressure. Okay, okay, where is it? Yeah, it is called the vapor pressure right here. Now, because it's the pressure that results from the vapor phase of the liquid. Now it has to be measured when the equilibrium is established. Though, how do you measure it? You can just simply measure by using something called a barometer. You saw this already in chapter 12. Now, if you don't have any liquid at all, you just the barometer itself composed of mercury, and then you have this vacuum tube. okay, inverted upside down. When you invert this vacuum tube in the mercury sample like this, the atmospheric pressure will push the level of the mercury to increase. And this is if you do this at the sea level, the level of mercury will increase to 760 millimeter. And this is why we call the pressure at the sea level 760 millimeter mercury. So now, if you want to measure the vapor pressure of something like water, you can actually inject the water into this tube. Now, because water is less than the mercury, liquid water will rise to the top. Now, because some of the water molecules here will vaporize and it will generate a vapor pressure. And that vapor pressure will push the level of the mercury down. And then down by how much? By 24 millimeter. So we say that, oh yeah, the vapor pressure of water at this temperature is 24 millimeter mercury. So now, water sample in liquid phase, it has the hydrogen bonding, right? This is between water molecules. So now if you have something that doesn't have hydrogen bonding, something that has only dipole-dipole intermolecular force, like diethyl ether, you inject diethyl ether in here at the same temperature, because diethyl ether has only dipole-dipole. It doesn't need that much energy to vaporize, to change from liquid phase to gas phase. So therefore, something like diethyl ether will have high vapor pressure. So in this case, the vapor pressure of diethyl ether is 545 millimeter mercury. So now, something like diethyl ether, which has high vapor pressure, that kind of compounds or that kind of substance, we say that they are volatile. And then usually molecules that has high that are volatiles, not molecules, the substance that are volatiles, those are the substance with uh those are the substance that has weak intermolecular forces. For example, if you have something like, methane, which has only London dispersion force, and then versus HF, this is hydrogen bonding, and this is London dispersion force. Something like this one will have it's going to be volatile. It will have high vapor pressure. Something like helium or compared to water. This is London dispersion force. This is hydrogen bonding. Of course, this will have high vapor pressure. This will have low vapor pressure. This is volatile. This is not volatile. So the last two things is this example. If you have water and methanol, you notice that both compounds has hydrogen bonding, but water molecule has two OH, can form hydrogen bond over here, can form hydrogen bond over here. Now in methanol, you take out one hydrogen and replace with the CH3 group. So you have only one side of the molecule that can form hydrogen bonding. So therefore, this molecule will be more volatile. It has higher vapor pressure. So now for B, you have only one OH group, same thing. Okay, one OH group. But this portion of the molecule right here, this portion molecule has a lot of electrons. Therefore, this molecule, in addition to having hydrogen bonding, it has big London dispersion force also. So this molecule will be less volatile. It will have low vapor pressure. And that's it.